Yes, students, we are on the second unit, that is the quantum theory, the next topic of the quantum theory. In the first topic, what you have studied, that what is quanta? Quanta means the particles or the electrons of energy, means the energy photons. Or what you have studied, that our electrons not behave as only a particle, but they also behave as a wave, means the sinusoidal or the cosinusoidal waves. For example, our light, sound waves, all these are the waves which have the particles which carries energy, and because of this they can move to a large distance, and this is the quantum mechanics or the quantum theory. Now today we are going to study the Heisenberg's uncertainty principle. Heisenberg is a scientist which gives the uncertainty principle regarding the particle and wave nature of the electrons. What is this? Heisenberg uncertainty principle is a key principle in quantum mechanics. Means this is considered to be one of the most important principle in the quantum mechanics means the science of energy photons. Very roughly, it states that if we know everything about where a particle is located, the uncertainty of position is small. We know nothing about its momentum, the uncertainty of momentum is large, and vice versa. क्या मीनिंग हुआ इसका? हेसनबर्ग इज अ साइंटिस्ट जिसने ये बताया था, he tells that if we have to study any particle, any electron, we must have a knowledge about its position and the momentum. Position होता है वो पार्टिकल कहाँ स्टे करता है, इन विच न्यूक्लियस इट इज, वेयर इट इज, एंड मोमेंटम मीन्स मोमेंटम इज द प्रोडक्ट ऑफ मास एंड वेलोसिटी. तो वो मोमेंटम ये कहता है कि व्हाट इज द मास ऑफ दैट पार्टिकल्स एंड बाय विच वेलोसिटी इट इज मूविंग, विच इज कैरिंग द एनर्जी, आवर क्वांटम मैकेनिक्स. But Hessenberg states that there is all, whenever we are going to study these two factors, that is the position and momentum, we are always uncertain. Uncertain means we are not sure about both the things simultaneously. That is, for example, if we know that where is the position of the particle, means if we know the position of the particle and it is and uncertainty about it is very small, means we are almost sure, about to sure that where the particle is, then uncertainty about its momentum, that is its mass and velocity, is very large. Or ulta bhi, and vice versa. It means if we are uncertain about its momentum, very small, then its uncertainty about its position is very large. Versions of the uncertainty principle also exist for other quantities as well as energy and time. Matlab, this principle does not only holds for position and momentum, but it is also hold for energy and time, that we are not very much sure about how much the energy each particle carries and how much time each particle takes to travel in the free space or in any medium. In quantum mechanics, that is the science of quanta, science of energy photons, the uncertainty principles, also known as Heisenberg's uncertainty principle, is any of a variety of mathematical inequalities asserting a fundamental limit to the accuracy. मतलब इस प्रिंसिपल ने एक लिमिट दे दी थी कि कोई भी वैल्यू अगर हम स्टडी करते हैं, वेदर इट इज एनर्जी, टाइम, पोजीशन और मोमेंटम, हम कभी भी 100% श्योर नहीं होते. एक लिमिट होती है कि टिल हाउ मच वैल्यू वी आर श्योर. Limit to the accuracy with which the values for certain pairs of physical quantities of a particle, such as position, momentum, can be predicted from initial conditions. मतलब अंडर सम इनिशियल कंडीशंस कि वो कहाँ से स्टार्ट हुई, किस कंडीशंस में स्टार्ट हुई, किस टेम्परेचर पर स्टार्ट हुई, किस वॉल्यूम से स्टार्ट हुई, we are always uncertain about its position and momentum. The uncertainty principle implies that It is in general not possible to predict the value of a quantity with arbitrary certainty even if the initial conditions are specified. वो कह रहा है कि मतलब हेसनबर्ग states that even if the initial conditions are known, still it's not possible to predict the value of a quantity with arbitrary certainty. मतलब हम random certain से किसी भी चीज को study नहीं कर सकते. Even if we know its initial conditions, we have to be a little bit certain only, but we are uncertain. Next, introduced first in 1927 by the German physicist Werner Heisenberg, means this Heisenberg scientist, its name is Werner Heisenberg, and he introduced this principle in 1927, and he was a German physicist. The uncertainty principle states that, again, what is the uncertainty principle? The second definition to be have more clarity. That is, the more precisely the position of some particle is determined, the less precisely its momentum can be predicted from initial conditions and vice versa. Means what this principle uh, states कि जितने अच्छे से, if we know the initial condition, then if we are very accurate about its position, then the more the accuracy in its position, the less the accuracy in its momentum, or you can say the momentum and the position are inversely proportional. The formal inequality relating the standard deviation of position and standard deviation of momentum was derived by Earl Hus Kennard later that year and by Hermann Weyl in 1928. मतलब हैसनबर्ग के प्रिंसिपल को एक्सटेंड करते हुए देयर वाज टू मोर साइंटिस्ट इन 1928, दैट इज अर्ल हर्स कैनॉट एंड द हर्मन वेल, हु डिस्कवर्ड about the relation of standard deviation, that how much deviation is in the position from the initial conditions, कितनी position deviate करती है और कितना momentum deviate करता है from its initial conditions. Uncertainty principle, also called the Hessenberg uncertainty principle or intermediacy principle statement, articulated by the German physicist Werner Hessenberg, that the position and the velocity of an object cannot both be measured exactly at the same time, even in theory. The same principle is again in terms of another language. फिर वही same principle है मगर language is different. कि Hessenberg, the German physicist in 1927 articulated, means states that momentum is basically the mass and velocity. Mass of a particle is always remains constant. So what is the actual factor which varies with the position is velocity. तो ही स्टेट्स दैट कि एक ही टाइम में पोजीशन और वेलोसिटी दोनों एक्यूरेटली नहीं डिटरमिन की जा सकती, इवन इन थ्योरी. It's practically, it is quite impossible. It's quite not impossible, it's quite difficult. But same is the case in theory. The very concepts of exact position and exact velocity together, in fact, have no meaning in nature. एक्चुअली इन नेचर अगर हम कहें कि हमने एक पार्टिकल की, एक इलेक्ट्रॉन की, एक क्वांटा की, एक फोटोन की एग्जैक्ट पोजीशन और एग्जैक्ट वेलोसिटी मेजर कर ली और एक साथ, तो इट हैज नो मीनिंग इन नेचर. The uncertainty principle arises from the wave particle duality. वो एक्चुअली जो uncertainty principle which was discovered in 1927 by the वर्नर हेसनबर्ग साइंटिस्ट, ये कहां से आया था? एक्चुअली फ्रॉम द वेव पार्टिकल डुअलिटी. वेव पार्टिकल डुअलिटी विच यू ऑलरेडी नो क्या था? द वेव एंड पार्टिकल नेचर ऑफ द इलेक्ट्रॉन. इलेक्ट्रॉन वेव्स both as a wave and both as a particle. Sometimes it behaves as a particle. For example, if we ask about the light rays, it behaves as a particle, that is the particle of light. But when we consider to be the sound waves, it behaves as a waves, that is the co-sinusoidal and sinusoidal waves. It means ये जो दोनों चीजें हैं कि कभी वेव की तरह बिहेव करते हैं, कभी पार्टिकल की तरह, that forces the Heisenberg to give the concept of uncertainty principle. Every particle has a wave associated with it, and each particle actually exhibits wave like behavior. इसने क्या कहा था वेव पार्टिकल डुअलिटी और हेसनबर्ग ने कि हर पार्टिकल अपने आप में वेव है, क्योंकि हर पार्टिकल जब मूव करता है तो इट एक्चुअली बिहेव्स लाइक अ वेव एंड ईच पार्टिकल एग्जिबिट्स वेव लाइक बिहेवियर. The particle is most likely to be found in those places where the undulations of the wave are greatest or more intense. वो कह रहे हैं पार्टिकल वहां जरूर होता है जहां पे वेव का अंडुलेशंस, दैट इज वेयर द लेवल ऑफ द वेव वाज ग्रेटेस्ट और बहुत एक्सट्रीम. फॉर एग्जांपल इफ वी कंसीडर द साइनोसाइडल वेव, इट इज वेरी वेरी हाई एट 90 degree. The more intense the undulations of the associated wave become, however, the more ill defined becomes the wavelength, which in turn determines the momentum of the particle. Means देखो whenever the particle behaves as a wave, it must have a wavelength. Wavelength means what is the length of the wave, that after how much length the wave, a particular periodic of the wave repeat itself, and this wavelength ultimately determines the momentum of the particle. So a strictly localized wave has an intermediate wavelength. Its associated particle, while have a definite position, has no certain velocity. Okay, whenever we consider the particle as a wave, its wavelength can be determined, its position can be determined, that where it is. It is at the 0 place, at 90 degree place, at a 45 degree place, but we cannot determine its velocity at the same time, that by what velocity it is moving. A particle wave having a well-defined wavelength, on the other hand, is spread out. The associated particle, while having a rather precise velocity, may be almost anywhere. अगर एक पार्टिकल की वेवलेंथ एक्जैक्टली डिफाइंड है, इट मीन्स इट कैन easily be spread, it easily have its periodic nature, but it can have any velocity at any time. A quite accurate measurement of one observable involves a relatively large uncertainty in the measurement of the other. एक चीज मेजर होती है, उसमें जितनी ज्यादा एक्यूरेसी, द मोर अनसर्टेन इज द measurement of the other thing. Yes. Now let's see this in the form of an equation. That is, Heisenberg-Verstein principle states that position and momentum are inversely proportional to each other. That is, delta x delta p is greater than equal to h upon 4 pi. What is the delta? Delta is the minor change in position. Delta always stands for minute changes and x stands for position. Delta P stands for minor changes in, that is the uncertainty in momentum. P stands for momentum, that is the mass and velocity. It is minimum equal to h upon 4 pi, and maximum is greater than h upon 4 pi, where h is the Planck's constant, which studies the energy of the particle in terms of photons, which is a constant number given by the Planck scientist, which studies the energy of photons as a particle. The Heisenberg uncertainty principle is a law in quantum mechanics that limits how accurately you measure two related variables. Means the position and momentum are related to each other, this is 100% sure, but are inversely. Specifically, it states that the more accurately you measure the momentum of a particle, the less accurately you can measure its position, and vice versa. Yes. Now, on the basis of this, we are going to study a Schrodinger wave equation that is given by the Schrodinger, a scientist. That is, it is one of the most fundamental equations of quantum physics. Means it is one of the equations which is very, very used in the quantum theory, in the energy of photons, in the theory of photons, that is the quantum physics. What is this equation? This is also called as a Schrodinger equation, and it is a partial linear differential equation and widely used in chemistry and physics to solve problems based on the atomic structure of matter. Matter का क्या मतलब है? Matter means anything around us which is made up of protons, electrons and neutrons, and it tells about its atomic structure कि कहाँ protons होते हैं, कहाँ electrons होते हैं, electrons actually what type of nature it shows, whether it is a wave, whether it is a particle. Schrödinger wave equation describes the behavior of a particle in a field of force or the change of a physical quantity over a time. श्रोडिंजर वेव इक्वेशन क्या थी, इसने बताया था कि हाउ आर पार्टिकल्स बिहेव इन अ फील्ड ऑफ फोर्स और द चेंज ऑफ अ फिजिकल क्वांटिटी ओवर टाइम. एरविन श्रोडिंजर, who developed the equation, was even awarded the Nobel Prize in 1933. Means it was given by a scientist Erwin Schrödinger. Schrödinger wave equation is a mathematical expression describing the energy and the position of the electron in space and time. Schrödinger ने क्या कहा था? He gives an equation जिसने कहा था कि whenever a electrons behave as a energy particle or a wave energy wave, how it behaves in space with time, how its position changes, taking in account the matter wave nature of the electron inside the atom. That inside the atom, electrons are present, and these electrons have the energy, and these electrons change in its position in space with time. The Schrödinger model assumes that the electron is a wave and tries to describe the region in space or orbitals where the electrons are most likely to exist. मतलब श्रोडिंजर मॉडल ने कहा था द इलेक्ट्रॉन बिहेव नॉट ओनली एज अ पार्टिकल and it behaves also like a wave and it exists in space or orbitals. Means जो बोर्स ने मॉडल दिया था उस मॉडल में accordingly to that in an atomic structure orbits are there, and in that orbits electrons are found to exist, and these electrons are basically the main source of energy. Schrödinger wave equation is based on three considerations: classical plane wave equation, Broglie's hypothesis of matter wave, and conservation of energy. What is this classical plane wave equation? That is, the electrons behaves as a wave. Broglie's hypothesis of matter wave, it means these electrons are a part of matter and these material particles behave as a wave. And conservation of energy means the energy is always conserved, it's neither created nor destroyed. जितनी electrons energy release करते हैं उतनी वो gain करते हैं. Schrödinger equation gives us a detailed account of the form of wave functions or probably waves that control the motion of some other particles. Means कि Schrödinger की equation tells not only the behavior of electrons as a wave but also about the wave function. This equation also describes how these waves are influenced by external factor. Means the position and the momentum of electrons are how influenced by the external factors. Moreover, the equation makes use of the energy conservation concept that offers detail about the behavior of an electron that is attached to the nucleus. Means our electrons are attached to the nucleus. All of you know that our nucleus has protons, neutrons and electrons, and electrons moves in the orbits, and while moving in the orbits they conserve the energy. Besides, by calculating the Schrödinger equation, we obtain psi1 and psi2, which help us determine the quantum numbers. What are these psi1 and psi2? These are the wave functions which are you about to study in next slide, which help us determine the quantum numbers as well as the orientations and the shape of orbitals where electrons are found in a molecule or atom. Means how these electrons move in the orbits, in which shape of orbits they move, and how much energy they carry, and how much quantum number they have, and what is their orientation. All these are studied by the wave functions psi1 and psi2. Now there are two types of Schrodinger wave equations, that is the time dependent equations and time independent. You can see below the time dependent equation. Since it is the linear partial equation, that is you can see the partial derivative, where you will see the h, this is called h bar, and it is the related to the Planck's constant, which studies the photon energy to its frequency, which is a quantum of electromagnetic action that relates a photon energy, means electrons act as a photons and these photons have the energy, and this energy is related to their frequency, how much it moves. V stands for the potential of these electrons with respect to R and T, that is with respect to space and time. And psi is the wave function that is time dependent, which varies in accordingly to time, and where you can see I is a complex number, that is the imaginary unit. And the time independent Schrodinger equation is in the compressed form, can be written as like this, which is S psi is equal to E psi, which H is the Hamiltonian operator and E is the energy eigenvalue. What is the Hamiltonian operator? Is the sum of potential and kinetic energy of particles calculated over three coordinates and time. Three coordinates means our three-dimensional x, y, z, and with respect to time, and it is the sum of kinetic and potential energy. Why it is a sum of kinetic and potential energy? Because whenever our electrons move, it not only carries the kinetic energy because they are moving, but it also carries the potential energy because they also changes their position with respect to time. This is only used where E is a constant equal to the energy level of the system. This is called eigenvalue. This is only used where the Hamiltonian itself is not dependent on time explicitly. Now, the concept of wave function. In quantum physics, a wave function is a, yes. In quantum physics, a wave function is a mathematical description of a quantum state of a particle as a function of momentum, time, position and spin. क्वांटम फिजिक्स में एक वेव फंक्शन क्या है? देखो क्वांटम फिजिक्स में वेव फंक्शन इज मोस्ट इंपॉर्टेंट. You have seen in the uncertainty principle, you have seen in the Schrodinger equation that all our electrons not behave only as a particle, but they behave as a wave. And in order to study the electron as a wave, we must have the knowledge of wave function, which is the quantum state, means the energy state of a particle, and which is a function of its four parameters: its momentum, that what mass the electron is carrying, by what velocity it is moving, in which time it is moving, what is its position with respect to time, and how it spins, means how it moves in the orbits. This symbol used for a wave function is a Greek letter called psi. This is the psi, it's called psi, p is silent. By using the wave function, the probability of finding an electron within the matter wave can be explained. ये वेव फंक्शन किस लिए यूज हुआ था? ये वेव फंक्शन से हम ये एक्यूरेस के, दिस इज द वे ऑफ प्रोबेबिलिटी कि कितने चांसेस हैं कि इलेक्ट्रॉन एटम के अंदर है एंड इट इज मूविंग इन इट्स ऑर्बिट, दैट एवरी मैटर वट एवर वी आर सीइंग सराउंडिंग अस इन द एरिया इन द यूनिवर्स, it is made up of matter and all matter have atoms, and in the atoms we have electrons. This can be obtained by including an imaginary number that is squared to get a real number solution, resulting in the position of an electron. What is this imaginary number? This is imaginary number is complex number, that is iota. And this iota when square we get a -1. Means position of electron is studied with the help of iota, and iota is squared to get a real number, to get the exact position of electron in the orbits in the nucleus of the atom. The concept of wave function was introduced in the year 1925 with the help of the Schrödinger equation. When the Schrödinger equation came the concept of wave function, that describes the wave nature of the particle or the electron. Schrödinger equation is defined as the linear partial differential equation describing the wave function psi. This equation is named after Erwin Schrödinger. This psi name is why this wave function is called psi. It is given after the name of the scientist Erwin Schrödinger. Using the postulates of quantum mechanics, Schrödinger could work on the wave function. Now, what are the properties of this wave function? All measurable information about the particle is available. With the help of this wave function, every information about the particle, that the electron is available, that is about our matter. Psi should be continuous and single valued. It should not be discontinuous. It's a continuous wave function. Using the Schrödinger equation, energy calculation becomes very easy. जो हमने एनर्जी की कि हाउ मच पार्टिकल एनर्जी, हाउ मच एनर्जी अ पार्टिकल हैव, हाउ दिस एनर्जी इज यूज्ड इन ऑर्डर टू स्टडी द डिफरेंट पैरामीटर्स. Probability distribution in 3 dimensions is established using the wave function. With the help of wave function, the probability distribution in 3 dimensions means how much is the probability that electrons are occurs in the orbits, and these orbits are used to study the particle nature. The probability of finding a particle, if it exists, is 1. When is the probability is 1? All of you know, and you have studied in maths. Then when the probability is 1, it means it is 100% accurate event. And if a particle or electron is found in the orbit which is existing as a photon of energy, the probability is 1. Figure shows the wave function is Schrödinger equation. This is the sinusoidal wave. Now, what is the significance of wave function? The wave function associated with the moving particles is not an observable quantity and does not have any direct physical meaning. देखो वेव फंक्शन क्या है, ये एक ऐसी नहीं है इस जिसको साइंटिस्ट ने डायरेक्ट ऑब्जर्व किया था. इवन वी आर डायरेक्ट ऑब्जर्विंग इट. It does not have any direct meaning, but it is attached to the nature of the electron or the particle of the matter. It is a complex quantity, that is iota. So how a wave function is studied? Wave function psi is a parameter of which depends on 4 parameters, that is x, y, z, t. X, y, z are our 3 dimensional plane, and t is time. And since it is a combination of a complex number and a real number, so it states as a plus iota b, and its conjugate is a minus iota b. And whenever the wave function is multiplied by its conjugate function, we get a real quantity, that is a plus iota b multiplied by a minus iota b, we get a square plus b square. This can represent the probability density of locating the particle at a place in a given instant of time. What this tells, that how much is the probability of locating a particle in any nucleus in any orbit. The positive square root of the product of psi and its complex conjugate is represented as the modulus of psi xyzt, called the modulus of psi. This is called as positive square root because actually its square root is a negative number, but when we take its modulus, it becomes a positive number. And it does not mean its value changes. It actually means that it exists but in the opposite direction. The quantity psi xyzt modulus square is called the probability function. That is the function which describes how much is the probability of finding an electron in an orbit. Yes, so you can easily see how what we have studied in this complete chapter, that is the quantum theory. The second lecture, that is what is about Heisenberg uncertainty principle. It's about the uncertain of position and the nature of the particle, its wave, then the Schrodinger equation, then it's two parameters, that is the Hamilton and the energy, that is the eigenvalue. Then how the wave function is associated with it, what is the properties of wave function, and actually what is the significance of wave function and what is wave function. Thank you. This all about this topic.